Here we go, here we go, here we go. One more time. Here's session 4. We're talking about quadratics and factoring, and holy cannoli, there is tons of details for this particular review. If you need a scrap graph again to glue in your vocab notebook, I would do that. Pause anytime you want to sketch all these little pictures, but there is tons of information here. So remember, a quadratic is anything that has an exponent of 2. So right here, I'm going to skip down to this for a minute. Standard form is our regular ax squared plus bx plus c. Factored form would be something like this. This is like a complete factoring problem where the a would be the GCF, and then this would be how the whatever is left factored. And then we also have the vertex form, which is the completing the square form, which I believe we've gone through before you see this video. But completing the square also can create what we call the vertex form of a quadratic. A quadratic is anything with an exponent of 2. So when we look at these two types of pictures, I put both of them, even though we still have, they're both labeled kind of the same. The reason why I did this is because what they're labeled with, though they mean the same, are a little bit different. Please remember that if you have a frowny face, in this particular picture, a frowny face will give you an a value that's negative. This is a negative a value in front of the x squared. This would be a positive. It's a a smiley face, so it's a positive a value in front of the x squared. The places where these cross the x-axis, now I've said this numerous times, you might want to add a few more extra notes to this. When we have the intercepts right here, the intercepts are called x-intercepts, roots, zeros, or solutions. And we see that we have the intercept here, we have solution, but they're also called the zeros or the roots. So you kind of want to write that down. You're definitely going to need to understand what that means because those words are interchanged a lot in the regions. The vertex is also called the turning point. The turning point can be a maximum, such as if it's a frowny face, or it can be a minimum, as if it was your smiley face. And where you can fold that graph in half is called the line of symmetry or axis of symmetry. The axis of symmetry equation is always x equals something. So this would be an axis of symmetry of x equals 1. This would be an axis of symmetry of somewhere x equals negative something between 0 and negative 2. It's not giving me an exact point there. So all of these pictures really show the same vocabulary words, but written in different forms. You definitely want to make note of those. Again, pause anytime you need to make some extra notes and guided notes. We should have already gotten through transformations. This is, I don't know if I can make this a little bit bigger for us just for a second without messing things up. Oop, there we go. So it's a little bit larger. Remember, this is a parent function. Back in video 2, I believe, we talked about the parent function of the absolute values. Well, this is the parent function of a quadratic. And so we can talk about the parent function and compare different graphs. So for example, these two things would be a vertical shift. The k, is it going up or down? So basically this would be x squared plus 3. This would be x squared minus 6. If you have an exponent, an addition or subtraction on the outside of this, then it tells you whether it's going to go up or down. If this had an f of x kind of inside, it's written a little bit differently. If you have x squared plus, say, 2, it's going to go, oh, actually, we'll use this graph. That looks like a negative 5 to me. So this would be f of x squared plus 5. Remember, it's backwards when they're inside the parentheses. Again, you can kind of memorize these. If you see a plus 3, it means up. A minus 6 means down. If it's inside the parentheses and it's squared, then you can remember that it actually goes backwards left or backwards right. So you can memorize these, or you can just plug it into your calculator. You can also dilate. Dilate means get bigger or smaller. When the coefficient is larger than 1, it gets narrower. It's called a vertical compression because it squeezes together up top. And then, vertical stretch. I'm so sorry. A compression is when it pushes together or pushes down. When you have a coefficient that's less than 1, it gets wider. So a vertical stretch is when it kind of goes upwards more. It's steeper. That's a bigger number. And then this is going to stretch it out a little bit less. It's going to push it down towards the axis. That means that the coefficient in front is less than 1. You can also flip this. If you reflect this, you have a negative in front. The coefficient of a negative means that it goes underneath the axis. The second part of quadratic review deals with factoring. What I learned is you guys are really, really good at factoring, but let's go ahead and review these steps anyways. Again, if you have to pause the video to get all of the notes, please do that. The first question you always ask yourself is whether or not there's a GCF. For example, in this case, did you hear that? For example, in this case, the GCF between the numbers is 5. There's an X in all 3, and there happens to be a Y in all 3 as well. So the GCF is 5XY. Remember, we do the ladder method. See if I can draw this in there a little bit. We do the ladder method. Woo! That is terrible. Where we draw this little thing and the GCF comes along the outside. I'm still not very good at that, but this is your GCF right here. Wow. And then what's left is in the parentheses. Remember, if you start out with 3 terms, you end with 3 terms as well. The second question you ask yourself whether there's a GCF or not, because remember, we can factor completely. The second question you ask yourself is whether or not it's a difference, difference, of 2 perfect squares. And if there is, it looks something like this. And you will have conjugates. Remember that word conjugates. I will spell that for you right up here. Conjugates end up becoming the answer. So conjugates are what you will have in your parentheses. X squared is a perfect square, 4 is a perfect square, y squared is a perfect square. It's a minus. So you take the square root of each one of those and they go in the parentheses. Don't let the number in front freak you out. Still the square root of 16, the square root of r squared, the square root of 25. The third question you ask yourself is whether or not there's it's a trinomial. Holy cow, this video's all messed up. My phone was ringing. I can't draw my line straight. Anyways, the third question we ask ourselves is if it's a trinomial, and if it is, if it has a coefficient of 1 out front, the a value is 1. Please remember that when we do this, we find the factors of the third term that add, that's our little trick, that's our shortcut. In this case, add, if that was a minus, it would be subtract, to that middle term. So in this case, the factors of 12 are 1 and 12, 2 and 6, 3 and 4, and the numbers, the pair that adds to the 7 are 3 and 4. This is the Dylan Brown look. He likes to do the little number first and the big number second. I like it the other way around, but either way, it doesn't really matter as long as you have the correct signs that go with it. The fourth question you ask yourself, and this is really the final question for this type of factoring, is if it's a trinomial and the coefficient is not 1. Now, I call this fancy factoring, but when I looked online, they call this the bottoms-up factoring. I don't know. I could start singing that song, but it's not really appropriate, I guess, for school. When the coefficient is not 1 and there's no GCF, you multiply A times C, and that's where you get your new trinomial, and the new trinomial then can factor. But don't forget, when you multiply by 2, you also have to divide by 2, because remember, we can manipulate anything, but we can't change the value. When you do this, the reason why they call this, whoever created this slide, the bottom comes up, so bottoms up method. I call it fancy factoring, they call it bottoms up. Either way, it's when a trinomial has a coefficient that's not 1. The last way to factor is actually not really a factoring at all. It's just kind of manipulating the problem. It's called completing the square. When we have a trinomial, you can do by completing the square, keeping the x's on one side and the constant on the other, so add 3 to both sides. This is where I would have drawn my box. So you put a little box. That's why I call completing the square. Whatever you do to one side, you have to do to the other. And when you do this, you take the b value, divide it by 2, and square it, and that becomes your new c value. And the whole purpose is to make a perfect square trinomial. In this case, this factors to x plus 1 squared. Now, vertex form, we've talked about. Vertex form is just bringing that constant back over to the left-hand side and then having an equal or a y at the end. So those are the quadratics. Quite a bit of information. A few setbacks here and there between my phone ringing and all my ugly straight lines. But other than that, I hope you had a great time listening. Talk to you soon.